Alright guys, this is the video to help out the two questions that I had in PAP Physics. If you're in my PAP Physics class and you really don't have any questions, then I must be an awesome teacher. But here we go. Here are the two questions that I had. The first one was about what happens to a ball if you're on a train and you drop it. Well, if the train, like if this is the boxcar, and you're in the train, alright, and you drop a ball and it falls, if the train is at rest, okay, you have a velocity equal to 0 and the ball has a velocity equal to 0. So if you drop the ball, it should just fall straight down. Okay. On the other hand, let's just erase this. Let's say that we're still in the boxcar, and here, we'll just redraw this real quick. Boop, boop, boop. Still in the boxcar. Still have a ball. This time, you drop the ball, and you and the boxcar have a velocity. So the boxcar is going at, let's say, 10 meters per second. It doesn't really matter, but just use 10 meters per second for the sake of argument. Well, if you're going at 10, if the boxcar is going at 10 meters per second, then you inside the boxcar are going at 10 meters per second, and the ball in the boxcar is going at 10 meters per second. So when you drop the boxcar, you will perceive the ball falling straight down. Okay? Now, the last setup is if the boxcar is accelerating. So here we have the boxcar again. Okay? And you're inside the boxcar still. Okay? Now, if you're in the boxcar this time and the boxcar is accelerating, let's say it's accelerating just at a 2 meters per second squared, okay? If the boxcar is accelerating at 2 meters per second squared, if your feet are touching the ground in the boxcar and you're standing upright and maintaining your posture, right, you will also be accelerating at 2 meters per second squared, okay? As long as the ball is in your hand, okay, as long as that ball is in your hand, since you're accelerating 2 meters per second squared, so is the ball. Because you're applying a force to the ball by holding it to keep it in motion. But when you release the ball, so as of right now, the ball at this point, we'll call it point A, at point A, the ball has two forces acting on it. One is the force of gravity pushing it down, and then the other one is your hand acting on it. And actually your hand is acting in the X direction on it to keep it going forward. Your hand is also acting in the Y direction to keep it up. Okay? So as soon as you, that's a Y, as soon as you let go of the ball, so if we let go of the ball is actually going to travel a path backwards. It's not going to fall straight down. Because at point B here, at point B, what's happened is that the ball now, since your hand released it, only has the force of gravity pulling it down. And that means that there is no x acceleration. So since there is no acceleration, it's going to fall straight down from where it was that you released it, which is technically back a little ways. So the ball will appear to fall straight towards you. And if you do not believe me, it's a logical thing to do. You shouldn't believe me all the time, because sometimes I accidentally lie. If you don't believe me, don't drive and do this, but have someone else drive and have them sit still in the car, and you drop a ball. If you drop the ball and you're moving at a constant speed, say 20 miles an hour down the road, when you drop the ball, you should see it fall straight into your lap. Same thing if the car is stopped. However, if you drop the ball and you're accelerating, like let's say that you have somebody hit the accelerator, and right as they hit the accelerator, you drop the ball should come into you a little bit. So if you're dropping it and it's hitting you at the knees, whenever whenever you're going at a constant speed or at rest, whenever you accelerate, the ball should hit you at mid-thigh or hit you in the stomach, because the ball is falling relative to where you released it, because it doesn't have any force acting on it in the X direction. Okay, the second question I had is, what would be how would the force on the ball look compared to the velocity of the ball at the top of the path? It doesn't really matter what angle it is. So in the problem, if you can figure out what problem this is, it shouldn't be that hard. But if you can figure out the problem, it doesn't matter what angle. This angle could be 60 degrees, it could be 70 degrees, it could be 80 degrees. So any angle between, as long as the angle is between like 1 degree and 89 degrees, it should work. Alright, as long as it's not at 90 degrees or at 0 degrees, this should be fine. But what happens is that the velocity of the ball at this point only acts in the X direction. So the velocity in the X will be there. The velocity in the Y, though, since it's at the top of its path, will be 0. So the only force acting, or the only velocity acting on it, is the velocity in the X. So we only have a velocity going that way. So this goes away. Okay? So we don't have any velocity in the Y. We only have the velocity in the X. So the force acting on it, since this is in the air, the only force acting on it is the force of gravity. And that acts down. So the force of gravity is going to be pulling it down, and the velocity in the X will be pushing it, or not pushing it, the velocity in the X will be carrying it on to the right, and it will have a 90-degree angle in between the force and the velocity. Okay? Hope those help. Remember, if you have any more questions, feel free to email me or Twitterish me. I don't know what it is. All right, so you know what to do. All right, have a good day.